section 1.1b, I actually split into 2 chunks. So on tomorrow, starting class, we'll do section 1.1b as well. It'll just be kind of a more difficult version of it, and it's dealing with square roots and radicals. This section, we're just kind of introducing ourselves to square roots and that all of them are perfect square roots and perfect cubes. And then in tomorrow's section, we're going to have to actually break them down if they're not perfect, okay? So what the whole idea of a square root, cube root, fourth root is, it's the whole idea that when you square that number, you get the inside number. So 4 is called the square root of 16 because if you were to square 4, you got 16. So how do we show the square root feature? The square root of 16 is 4. Okay? And Lindsay, if you want to just put that off to the side, you'll have time, I promise, at the end of class. Okay? So 4 is called the square because if you squared it, you got 16. 5 is called the square root of 25 because if you squared 5, so how are we going to show that notation? What's the square root of 25? 5. But we can do more than just square roots, and this is typically where maybe it's kind of new to you guys. You might not have seen cube roots or fourth roots or a higher root, but you can do any power that you want. So 4 is called the cube root of 64 because when you cube it, you get 64. So what you do is you write a little 3 inside the root. So that's the cube root there. And you say, okay, what are we cube rooting? 64, and we'll get 4. So it's just backwards. Addition undoes subtraction. Division undoes multiplication. Taking roots undoes squaring or cubing or whatever it may be. 3 is called a fourth root, so you're going to do something very similar. You're going to say the fourth root of 81 is 3. Is that okay? How many of you seen a higher power than a square root? Have you guys seen cube roots and fourth roots before? It's the same idea though, right? The square root, what one number times itself twice gets you to that? What number 3 times itself gets you to that? It's just the same idea. So the general form, let's write this general form and we'll star it because it's kind of the main guy, is whatever exponent you're talking about is the guy that's in the root, okay? So inside your little root, you'll put an n, and what are we taking the root of? The bigger number that's on the other side, b. And what comes out? Whatever we raise the power to. So I want to kind of label things, all right? So the guy under the inside is called the radicand. And that's one of the uglier words in math, I feel like, radicand, okay? So whatever you're taking the root of, it's called the radicand. And then whatever root you're taking, so that little n, is called the index. So I might say, well, what index do we have? And you'd have the third or the fifth, depending on what root you're taking. Okay? And what comes out is obviously your answer. So looking at evaluating radicals, just something to keep in mind, whenever you have an odd index, you can get negative answers. So like if you have a negative under your radical, a negative can pop out because an odd amount of negatives is negative. But be careful because whenever the index is even, you only have one possible result and it's always positive. It's called the principal root, okay? Because you can't take 2 numbers times itself and get a negative. 2 positives multiply to be a positive. 2 negatives multiply to be a positive. So there's no way to get that negative there. So I'll show you when we're doing all this. So real quickly, cube root of 125, you're like, I don't know. Guess what your calculator does? Oh, ho, ho, it does cube roots for you, okay? So on your calculator, if you go to the math button right here, you'll find cube root right at number 4, okay? So you'll hit number 4 and you'll type in 125 right under it, and what pops out? 5. Those that don't have a graphing calculator today, you can still play around with it on your cell phone. You can do 2 times 2 times 2, oh, that only gets me to 8. 3 times 3 times 3, that gets me to 27. 4 times 4 times 4, that gets me to 64. 5 times 5 times 5, oh, it gets me to 125. Cube root of 8, it's the same idea. 8's very small, so what's the smallest number we can really deal with? 2. What's 2 times 2 times 2? That is 8. So the answer is 2. All these roots, guys, I would just be thrown into my calculator, all right? So this is what I was talking about, negatives. Whenever you have an odd index, so this is an odd index, a negative's going to pop out. Why? Because negative 2 times negative 2 times negative 2 will be a negative number, right? Negative 2 times negative 2 will be 4, but then what's 4 times negative 2? Negative 8. So if you have an odd index, negatives will pop out from there. Not always the case with evens, okay? Fifth root of 32, you're like, well, Molly, how am I supposed to do that? He's a little bit different. So whenever you get to a power higher than, an index higher than 3, you have to type the index first, okay? So we're going to type 5 because we want to take the fifth root, and then we're going to hit math, and we're going to go down to this random one that has that x. So this is technically, it doesn't look like it, but that's the fifth root, and we'll type 32 right, and 2 will pop out. Again, if you're not too sure and you have your calculator or a basic one, you can do 2 to the 5th, 3 to the 5th, 4 to the 5th. Pick the one that matches 32. Because you guys, even with your calculator, you said when you turn it sideways, it does the powers. Yeah. So just work backwards. Take numbers to the 5th power until you get to 32. Take numbers to the 3rd power until you get to 8. All right, these are a little bit easier. What's the square root of 16? What number times itself gets you to 16? 4. And then this is kind of interesting. What number times itself 4 times gets you to 16? 2. And again, you could play with it. You could do 2 to the 4th, 3 to the 4th, see what you get to 16. All right, so this is the kicker that I was talking about. What number times itself twice gets you a negative number? It doesn't exist, right? You might want to say negative 4. But what's negative 4 times negative 4? Positive 16. There's no way to take one number times itself and get a negative. So this is called no real number.
We don't use
I.
We don't use
Not yet.
numbers yet.
We don't know about it yet. Keep that in mind though, Braden, because guess what? He's going to come into play in a couple chapters. Okay, so what he was mentioning is we eventually learned, like, notice I say no real number, because the numbers that we grew up learning were called the real number system. But you're going to find out in this class there's a whole nother number system called the complex number system. And you feel like you've been lied to your whole life. And such a number does exist, and that's what he was talking about. All right, what about the negative on the outside? Is that okay?
Yeah.
Yeah, right? Because we can do that part. Order of operations, right? What do we have to do first? The square root. What's the square root of 16? 4 with a negative in front. What's our answer? Negative 4. So anytime the negative's on the outside, guys, just bring it straight down. And then what's the square root of 16? 4. Then you get to fractions. You're like, oh my gosh, they're so scary. They are not. Just take the square root of the top and the square root of the bottom, okay? So what times itself twice gets you to 25? 5. What times yourself twice gets you to 49? 7. You just found the square root of 25 49s. It's 5/7. How do you do that in your calculator? You can just type it actually kind of like that. You can do square root of 25 divided by 49. It's going to give us a crazy decimal. But my favorite button, Math Frac, changes it to that fraction that we like. Are there any questions on the front page? All right, so the back page is just telling you guys, not every radical is that perfect radical. A perfect radical means when you take that index, that root, you get a whole number popping out, right? So sometimes we just have to put it in our calculator and see what it is, roughly, okay? So in your calculator, we're going to put the square root of 13 in your cell phone. Feel free to do it too, do it sideways. I think on your cell phone, though, you have to type the number first and then hit the square root button, okay? So in your calculator, when you type the square root of 13, oopsie, you're not seeing it, are you? You get this number, 3 something, and I want you to round to the nearest thousandths, tenths, hundredths, thousandths. That's 3 decimals, okay? So if we're going to round to 3 decimals, we're going to count over 1, 2, 3. That 5 behind that 5 makes that a 6. So we have 3.606. Does that look okay? And those guys, since they're not perfect squares, you will have to just put them in straight. So did you type 13 and then the square root, or do you?
I don't think you can do that. I don't know what it would be from here.
Square root right there. So type 13, and then that square root button. There it is. Okay.
Oh, okay.
So then, guys, kind of keep in mind, 13 is not a perfect square, but what numbers, perfect squares, straddle it? 9 and 16. What's the square root of 9? 3. What's the square root of 16? 4. Notice our answer falls between 3 and 4. So it's kind of like a rough idea. Square root of 137, I don't know it. Let's throw it into our calculator. Rounded to 3 decimal places, you have 704. The 6 makes that 4 go up to 5. So you have 11.6 0.705. Is that all right, guys? Is that what you're getting on your calculators? And again, what perfect square is 137 between? 121, which is square root of 11, and 144, it's square root of 12. So our answer is between 11 and 12. Cube root, remember with cube root on your calculator, it has its own button. If you hit math and scroll over to the cube, you have 300. And even on your calculator, I think you have a cube root, don't you? Okay. So what do we get? 6.694, because that 3 makes the 4 stay the same. Is there anything there? Is that all right? You can't really see my decimal. So whenever you don't have perfect squares, sometimes they just say throw it in your calculator and round. Tomorrow we're going to actually learn how to break them down and reduce them but keep them in radical form. So we'll talk about that then. Examples 1, 2, and 3 are just making sure that you can appropriately evaluate roots, because sometimes how you type it in will make a difference, okay? So here we have t. It's approximately how many seconds, so a t stands for time, it takes for any object to hit the ground when it's dropped from a certain height, h, okay? So say we're on this building and this building's 60 feet tall. We would plug 60 in for our h, do the math, and go from there. So we have order of operations going on. Notice the square root's the last thing you're going to do. The multiplication is going to be the first thing you do. The division is going to be the second thing you do, okay? So if our h is 7, we're going to have t equals the square root of 2 times 7 over 32. And so I kind of just work inside. If you want to do it all at once in your calculator, you can. But I just do the multiplication first. What's 2 times 7? 14. So we want the square root of 14 over 32. Do you have to reduce that? No. Since it's not a perfect square, just throw it in your calculator. So on your calculator or your cell phone, you can even type 14 divided by 32, hit enter, and then take the square root of it. So we need to round to 2 decimals. It'll be 0.66. And then since it's representing time, we have a unit, which is seconds. So that's probably just me, like holding my hand up, right? Like 7 feet. So if I just dropped something from over my head and dropped it, it would hit the ground in roughly 66 hundredths of a second. Is that all right? B is the exact same idea, guys, but we're raising our height here. We're going up to 100 feet, but you're going to do the exact same thing. T equals 2 times 100 over 32. Do the multiplication first, so 200 over 32. But then in our calculator, let's find out the square root of 200. Did you get that first one to work? Let's see real quick.
It gave me 5.6.
Okay, so we'll just make sure we're going to do the square root first. So we're going to do, the division first. So 14 divided by 32, hit enter first, then take the square root. Oh, it's still not doing it.
You have to clear it. I don't know.
Yeah,
I
I wanna
tried it and
clear
it
it.
just didn't.
Yeah, 14 divided by 32, hit enter, and then the square root. There it is.
Yeah,
you
yeah, I
just
didn't
wanna
press
clear
enter
out all that.
first.
Okay, yeah, enter, because otherwise it's just taking the square root of 32.
Yeah, that makes sense now.
What do you guys get on this one?
2.5.
Perfectly, isn't it? 2.5 seconds perfectly? Which still amazes me, because 100 feet's pretty high, and it doesn't even take 3 seconds to go from 100 to ground 0, okay? All right, the last two are important. It's one of those things that we want to make sure when we plug things in that we understand where they're going, okay? So notice on 2, it's the square root of all of it, x plus 9, and on number 3, it's just the square root of x. Get that answer, and then add 9. Okay, so on number 2, we're going to do y equals the square root of x is 16, so we're going to do 16 plus 9. But notice the 16 and the 9 are all under the square root, so do that first prior to taking the square root. So what's 16 plus 9? 25. And then what's the square root of 25? Perfect. Is that okay? So notice the addition is under that square root. So order of operations, it's like a grouping method. You got to do that stuff first, then take the square root last. Here, though, on number 3, again, x is still 16. But notice the square root is only with the 16. So order of operations, what are we supposed to do first? The square root, right? So we're going to do the square root of just 16. What times itself gives you the square root of 16? 4. And then 4 plus 9 is 13. So notice how those answers differ, just whether you're taking the square root of the whole thing or just the x.